Simpson paradox. In this short video, I'll discuss the following topics. Topic number 1. What is the definition of Simpson's paradox? Topic number 2. Example number 1. Judges A and B. We look at aggregated data, and we'll also look at unaggregated data. Topic number 3. Example number 2. UC Berkeley admission data in 1973. Acceptance rate for men is 44%. However, acceptance rate for women is 35%. So based on this aggregate data, there's a huge difference. Our question is, any gender discrimination against women? Topic number 4, example number 3, Mary and Tom. So actually, user or my students can make up your own data. Then we look at the result. Topic number 1. What is the Simpsons paradox? The reversal of conclusion based on aggregated or summary data and unaggregated data or detailed data is called Simpson's paradox. Example number 1. Judge A is better than Judge B in every type of courts. However, the annual result offers an opposite result. B is better than A. Example number 2. Athletes A is better than B in 100, 200, and 400 meter races. However, B won more medals than A last year. Here we assume they both participate the same number of races. Financial analyst A is better than B in every field. However, B's annual success rate is higher than A's. Topic number 2, example number 1. Judges A and B. There are two types of the data set. One is aggregate. The first part is aggregate, and the second part is unaggregated data. Source of data. If you are taking my course right now, you can simply type .Simpson paradox. P is capital P. If you're not taking my course right now, then you can download the dataset at my webpage. Here we try the first method to get the data. Simply type .Simpson. Then you get data. Okay. So actually we have 3 data sets. Example 1, so this one. Aggregate data, so this is unaggregate data. Example number 2, and we are going to copy this part, and example number 3, we copy this part. The first one, let's copy it twice. Okay, so this first one is aggregate data. We simply copy and go to Excel. So we launch the Excel, then we paste our data there. Because this data set is not separate nicely, so we have to choose the column, then click data and text 2 columns, and because it's the comma separated, so we use comma, it's nicely separated into 3 columns. Then we click finish. Okay, so let's make it bigger. Okay, and first one we calculate the total and how many trials for each of them. So total is the summation of upheld or reversed. So actually it's summation of 2. For Judge A is 150, and for Judge B is 125. Okay. Then we look at the performance. The performance is upheld divided by total. So for the first one is 129 divided by 150 divided by B5. So we can manually enter. So it should be B3 divided by B5. So it's 86%. And Judge B is 88%. So actually, obviously, 88 is higher than 86. Judge B is better. Okay. So this is our aggregated data. So actually, it's all we can call it summary data. So let's look at unaggregated data. Okay. So let's go back to Excel. No, sorry. Let's go back to R. We copy the second proportion of data. So this is unaggregated data. And we paste it. This time it's nicely separate into 1, 2, 3, 4, 5 columns. Okay. So there are two types of calls. One is called the common pleas for Judge A, and municipal called for Judge A as well. So column B, column C is simply for Judge A. Column D, column E is for Judge B. So we compare orange with orange. Then we calculate total and we calculate performance. Same thing. The total is summation of 29 plus 3. Actually is 32. And the performance again is upheld divided by total. So this is 90.6%. Okay, so let's copy and paste. So actually the red one compared with the red one. So one is 90.6, another is 90. So actually Judge A performance better for category 1. So let's compare apple with apple. Okay. Then we can use if function. So if the ratio for Judge A is higher than ratio for Judge B, then we enter better. Otherwise, nothing. Okay, so Judge A is better for the first type of the court. So let's look at the second category. Judge A also performs better. So according to unaggregated data, Judge A performs better than Judge B. However, based on the aggregated data, Judge B is a better one. So these two are opposite to each other. Okay, so what's wrong with the data? Now let's look at why we have reached two opposite results based on summary data and based on detailed data, or aggregated or unaggregated data. Okay, so we have like 5 columns. Okay, and column B and C is simply for Judge A and upheld. So these two are successful, these two are not successful. Similarly, D column and E column for Judge B. Okay, the first step, so let's calculate total. So total is a summation of success and failure. We put them together. So this is total. So we simply copy and paste. Okay, so let's look at a successful rate. Okay, both. Okay, successful rate. The success rate for common pleas. Okay, common pleas is simply for Judge A, successful upheld number plus for B. Okay, so 29 plus 90 belong to the same court. Divided by total, right? Total is 32 plus 100. So this is a success rate for common pleas, and success rate is 90% if we combine the cases from Judge A and Judge B together. Okay, so this is, this should be common plea. Similarly, let's look at municipal court. Okay, the successful rate, same thing. So this is successful for A plus the successful for B divided by total. The total is 118 plus 25. Okay, so if we look at these two numbers, okay, and for the common pleas, the type 1, we have 90% successful rate. Okay, for the second one, we have 84. So let's format it. So use percentage. So it's so this is much lower. Okay, this is a much lower rate. Okay, much lower rate. One is 90%, one is 84%. So let's look at Judge A. So what is the percentage for lower? So let's look at this lower one. Okay, so Judge A, so equals, so this is municipal, right? So this is Judge A. So this is total divided by summation. Summation is 32 plus 118. Sorry, something's wrong. Let's do it one more time. Okay, so this is equals, and municipal court divided by summation of these two, 32 plus 118. So for Judge A is roughly, so let's make a percentage. Make it a 0. So it's 78%. So let's look at Judge B. And same argument. okay, equals B 25. I should use parentheses. Let's do it again. So this is 25 divided by 100 plus 25. So it's only 20%. Okay, so here is the reason. Okay, there are two types of cohorts. One with high success rate and another one is lower success rate. For Judge A, unfortunately, her rate for lower success rate is much higher than Judge B. So this is the reason. And if we look at the aggregated data and we ignore another hidden variable called type, because based on different type and we have different successful rate. Okay, so this is hidden variable called type was. So this is the reason. There's another variable. Topic number 3. Example number 2. UC Berkeley admission in 1973. In 1973, UC Berkeley was sued for gender bias because their graduate school admission figures showed obvious bias against women. So actually look at here, admitted. 44% for men and 35% for women. Based on just the 6 departments, so this is 44% versus 30%. I called aggregate data. Okay, we have data based on 6 departments. The aggregated data acceptance rate for men is 44%. Acceptance rate for women is 30%. Any gender discrimination? Go back to R, we copy, then we launch Excel, and we paste it. Just copy and paste. So this is UC Berkeley 1973 admission data. Okay, and in total there are 6 different departments. Okay, column B is for admitted for male, and denied for male is column C. Column D and E are for women. So let's look at the acceptance rate for men. So we replicate 42 versus 35, actually 30. So column D is total admitted male divided by summation of column B and column C. So column C will be denied total. So it's a summation of column B and column C. So roughly about 44%. So this for men. So let's do exact same thing for women. Same thing is total admitted divided by total applied. And total applied is simply admitted plus rejected. So roughly it's about 30%. Sorry, it's not 33%, it's 30%. So these two values, based on aggregate data, is 44% versus 30%. So let's look at the individual department. Okay. And for men and for women, for men is accepted divided by applied. Applied is summation of two values. And so this is 62%. We copy and paste. So it's 60%. Okay. Similarly, now let's calculate acceptance rate for women for individual department. So it's D5 divided by summation of D5 and E5. Admitted divided by total applicants. Then we copy and paste. Okay. Now let's look at which rate is higher. Compare women and male and female. Okay. So let's use if function. Higher rate. Okay. If the rate for women is higher than men, then we type higher. Otherwise, for yes, otherwise we enter nothing. So double quotation, nothing. So yes, and then we copy and paste. So based on this, on aggregate or detailed data, with 4 out of 6 departments, women have higher acceptance rate.
Shutterstock.
First, we go back to R to copy the data. Because the data is so simple, I made it myself. You can enter your own values. Okay. So make it a little bit bigger. So we have 2 employees, Mary and Tom. Assume Mary is more experienced financial analyst, and Tom is less experienced. Okay. And the revenue, we do not use it up to now. So Mary for country A is 70% and 60% for Tom. For the type B, Mary is 50%, Tom is 40%. So actually, Mary is always performing better than Tom. Okay, let's assume we have 100 projects each. Okay, they are going to take 100 projects for both financial analysts. So let's look at Mary and Tom's performance. Okay, so I call this case number 1. So 100 and potential projects, and for Mary, focus on A. So only type A for Mary. And for Tom, it's opposite. Tom is also taking 100 projects last year. So let's look at their performance. So performance for Mary is 100 times corresponding successful rate. is 70%. Of course, it's 70. Okay. For type B, it's number of the project. Sorry, this should be F5. I'll copy and paste because Mary doesn't take any project type B. That is 0. The summation will be G5 times H5. Sorry, plus. Okay, summation of it will be 2. Okay, so we copy paste. And for case number 1, and Mary performs better. Here we just assume Mary have 100 type A, Tom 100 type B. Okay, 100 0 and 0 100. So we call this case number 1. So let's look at case number 2. Case number 2 is just opposite. For Mary, type A is 0, type B is 100. Just let's switch. 100 type B for Mary and 100 A type for Tom. So it's 0, 100, 100, 0. So let's look at the performance. Performance is number of A times corresponding success rate. So it's 0 because it's 0 project. Now 100 times 50%. So without calculation, we know is 50. Similarly, so let's look at the performance of Tom. Tom is 60%, right? It's 60. So the performance for case number 2, Tom is better. Because the total value, no, that's not correct. So summation of 2 actually should be 50. Summation of 2 should be 60. Okay, the case number 1, Mary performs better. For case number 2, Tom performs better. Then we can choose case number 3, case number 4, based on your change. Okay. So question is why? Why they have a different performance? Even Mary has a better skill set for both types of projects.
Shutterstock Music.